Hello guys, I want to show you how to answer a few questions that concerns or involves distance time graph. So with me here I have let's say how many questions are here. There is one, two, there are three questions that I got from a past paper. So let's start with number one. Now a girl rides her bicycle along a straight level road. Figure 2.1 shows a graph of her distance moved against time. Describe her motion between A to B, B to C, and C to D. If you can remember what we did in class, let me just show you briefly. This is what we did in class about so summary of distance time graph. It's down here, just a minute. Oh, wonderful, it's here. Just have here, I'm just going to take a snapshot of this, just a screenshot. Okay, just take this, then we're going to compare it with what we have from the question, which is this one here. Alright, so we have the diagram there. Okay, so if you can able to compare, look at AB. AB corresponds to this graph C, and graph C represent a body that is increasing in speed or accelerating uniformly. So that means AB, the body is accelerating uniformly. BC is a straight line which correspond to this part, which correspond to B. B means the body is moving at constant speed. So we are talking about constant or steady speed. That is for part B. Then CD correspond to this graph D, which means, as you can able to see, the gradient is decreasing or the steepness of the graph is decreasing. So that means that the body is slowing down, or we can say it is decelerating. It is decelerating uniformly. That is for that part of the question. Now, part B, we are asked to calculate the average speed from A to D. Average speed from A to D. All right. So what we know is that average speed is given by total distance over the total time taken for any given journey. Now between A and D, you can able to see the distance here was 400 meters, which was covered within 60 seconds. You can able to see the unit for time is here, the unit for distance is here. So that means we have 400 meters divided by 60 seconds. So we'll have it here. That is 400 meters divided by 60 seconds. 0 cancel with 0. 6 goes into 40. That is 6 times. Remainder 4. That is 6 2/3 meters per second, which is the same as 6.7 meters per second into two significant figures. What is her maximum speed? Now, to find the maximum speed, we look at the regions. Region CD, the body is slowing down. Now BC, there is constant speed, and then AB, we have the body is accelerating. So the high speed, we are supposed to look at part of the graph which is steeper. So if you look at point BC, we can able to read the value that is that. So you look at the part, the high speed will be between B and C. At C we are going to read the value at C, that is somewhere here. So that is 40, 41, 42, 43, 44, 45. So that means that is 45. Then at point B we have, that will be 10, 10.1, 2, 3, 4, 5, that is 15. And then distance, if we read towards the other side at C, at point C the distance is at this point here, that is 300, 310, 20, 30, 40, 50. So this is 350. Is it 350 or 360? Let's look at it again. 300, that is 310, 20, 30, 40, 50. Okay, so at that point that is 350. Then at point B, if you can able to read the graph, that is this point here. As you can see, this will be 90, 80, 70. So this is 70. So the speed there will be change in distance over change in time. That is 400 minus 70. 400 minus 70 divided by 400 minus 70 divided by, that is 45. 45 minus 15. 45 minus 15. This will give us 330 divided by 45 minus 15, that is 30. So we'll be able to have, that will give us 11 meters per second. So we divide 33 divided by 3, that gives us 11 meters per second. This is the high speed, if you can able to look at the graph, which is steeper. Alright, number 6, according to our question here, this can be number 2. Now in the figure below shows a distance time graph of a body that is in motion. Part A, Roman 1, describe the motion shown for the first 2 seconds, calculating any relevant quantity. Now using the graph, the only relevant quantity we can able to calculate here is the gradient of the graph, which represent the speed. So if you can able to see at this point here, time here is 2 seconds, and then at this point here, distance covered, that is 5 meters. So that means that the speed will be 5 meters divided by 2 seconds, which gives us 2.5 meters per second. So therefore here, to describe the motion, we can say that the body, this object was moving at a constant speed of 2.5 meters per second, and that will award you those 2 marks. Let's look at the next question. That is Roman 2. Now after 2 seconds, the object accelerates. Sketch a possible shape of the graph for the next 2 seconds. For the next 2 seconds. So for the next 2 seconds, that is from 2, that means you're going to have 4. So if it accelerates, then we've been given the time. We don't have the distance, that means you're going to sketch. So if you look at this graph here that I shown you earlier, this part C here, this graph C here represent a motion, a body that is moving at increasing speed or accelerating. So for the next 2 seconds, we're just going to have a graph whose gradient is increasing up to the next 2 seconds. That is up to that point. So any relevant, it must be a smooth graph where the steepness is increasing. Part B of the question, describe how a distance time graph shows an object that is stationary. An object that is stationary will have, you will draw a horizontal line which is parallel which is parallel to the x-axis, and the x-axis here is where you apply the time. According to the graph that we have here, that will be this graph, graph A. Now, having answered those two questions there, then I'm sure you'll be able to answer the question that I'm going to post in the Firefly. That will be the Google form. From here, you'll be able to attempt all those questions, and if there's a problem or there's a question or something that is not clear, you will let me know, and then I can able to take you through one by one. That is all.